One of the biggest debates in AI right now is whether you really need a giant model like the new GPT-5 or if a smaller, more efficient model can get the job done just as well. Large language models have dominated the headlines because of their power and versatility, but they also come with massive costs, latency issues, and privacy concerns that make them hard to use in every situation. At the same time, small language models are quietly proving they are not just lightweight alternatives. Smaller architectures are now reaching performance levels that compete with larger models, especially when fine-tuned or paired with retrieval techniques. The challenge for teams today isn't just understanding how these models work, but deciding when to use one or the other. In this video, we're breaking down small language models versus large language models. What's the difference and when should you use each? If you find this video helpful, please give it a like and subscribe, and let's jump right in. What are large versus small language models? Large language models are AI systems with tens or even hundreds of billions of parameters. These parameters define how the model processes and generates language. The most recent examples include GPT-5, which comes in several variants to balance power with efficiency, and Gemini 1.5 Pro from Google, which is designed for complex reasoning and multimodal tasks. These models are extremely capable, but require significant computer resources to train and run. By contrast, small language models have fewer parameters, usually in the range of 1 to 10 billion, and are optimized for efficiency. Popular examples are Microsoft's 5 Mini, which match or even outperform much larger models on reasoning and coding benchmarks. Open source models like Mistral 7v also demonstrate strong performance despite their smaller size. These models are lightweight enough to run on local machines or edge devices, making them practical for many everyday applications. In short, both large and small models can generate human-like text. The main differences lie in scale, cost, and deployment. Large models provide more versatility and deeper reasoning, while small models deliver faster, cheaper, and more private solutions. Use cases by model size. So, when should you pick a giant model versus a smaller one? It comes down to the job at hand, of course. Large models are best for complex reasoning and creative or open-ended tasks. These are your general-purpose chatbots and AI assistants that need broad knowledge and context. Models like GPT-5, Claude 3.5 Sonnet, and Gemini 1.5 Pro can analyze data, write professional reports, generate code, and hold nuanced conversations, all with a single system. That versatility makes them valuable in enterprise environments where a wide range of tasks need to be handled by only one model. Small models, on the other hand, are ideal for narrow, specific tasks where speed and efficiency really matter. Some examples are domain-specific chatbots, for example, medical Q&A, personal AI assistants running on your device, or coding autocomplete tools integrated in your IDE. These models can be fine-tuned for specific industries and perform nearly as well as larger models in that domain. Because they are lighter, they also deliver faster responses, run locally, and can be integrated into products with fewer infrastructure demands. Do you have a favorite use case for AI models? Leave a comment and let us know what you're using them for. Cost and privacy. One of the biggest differences between large and small models is cost and control. Large models like GPT-5, Claude 3.5, or Gemini 1.5 are usually accessed through cloud APIs. Even with 2025's more competitive pricing, high volume usage adds up quickly, and you are also paying for latency and infrastructure complexity. Consider that every query leaves your environment. This creates data governance challenges. Small models, on the other hand, are much cheaper to run and can often be used free or at a fraction of the cost from that of large language models. Open source options can be downloaded and run on your own infrastructure. Small models, on the other hand, are much cheaper to run and can often be used free or at the fraction of the cost from that of the large language models. Open source options can be downloaded and run on your own infrastructure, often with commodity GPUs or even laptops using tools like Ollama or optimized libraries like LLM. That means lower operating costs, faster responses, and most importantly, full control over your data. For industries like finance and healthcare, or any company handling sensitive information, this is not only a convenience, but a compliance requirement as well. Is small good enough? Not long ago, smaller models were dismissed as limited compared to AI giants, but that perception is changing quickly. Small models are catching up to their larger cousins in capability, in some cases, even beating them on specific tasks. How is this possible? Innovations in training using high-quality datasets and clever techniques are boosting small model performance. Models like 5.4 Mini and Mistral 7V now deliver performance that rivals much larger systems on reasoning and coding tasks, and in some benchmarks even outperform GPT-4 in narrow domains. With careful fine-tuning and curated training, a 7V model can be tailored to legal, financial, or medical uses and deliver results nearly identical to larger models, but at a fraction of the cost. Two techniques are key here. The first one is fine-tuning, which means taking a base small model and training it further on your specific data or task. Because of their size, SLMs are relatively easy to fine-tune and can quickly adapt to the new domains. Meanwhile, the second, retrieval augmented generation, lets a model fetch information from an external source, for example, a database or documents, in order to improve your answers. This means a small model doesn't need to contain all the knowledge. It can retrieve facts when needed, staying lightweight but informed at the same time. Together, these two approaches let small models stay lightweight while still informed and accurate. Of course, they are not a full replacement for large language models. You won't get the same depth of reasoning, but for well-defined, high-volume, domain-specific tasks, the small models can be a more efficient option. When to use which? With all this in mind, how do you decide which model size to use? It comes down to context. If your task is highly complex, creative, or open-ended, like writing long-form reports, handling unpredictable user conversations, or solving tricky reasoning problems, a large language model is likely to be the best choice. The big models excel at being general problem solvers with deep knowledge. They are the everything expert. You might pay more or wait a bit longer for a response, but you will get top-tier results. If your task is more straightforward, domain-specific, or resource-constrained, you are probably better with a small model. For example, answering frequent asked questions on a website, running an AI assistant on a smartphone, or providing quick code snippets. With fine-tuning or retrieval augmented generation, small models can match or even surpass large models within their niche, while being cheaper, faster, and more private. In reality, most organizations will adopt a hybrid strategy, deploying small models for routine or high-volume workloads while relying on large models for complex, one-off, or multi-domain tasks. At ClickIT, we have seen this played out across fintech, healthcare, and SaaS teams. Small models run reliably in production for repetitive structured tasks, while large models power the deeper analysis and intelligence layers. The key is designing your architecture so both can coexist, using the right tool at the right time. At ClickIT, we're helping companies design AI systems that balance cost, performance, and privacy by combining the right models for the right jobs. Now, I would love to hear from you. Are you experimenting with the small models in production, or do you still rely on large general-purpose LLMs for most of your work? Let us know in the comments. And if you enjoyed this quick comparison, subscribe to ClickIT for more AI insights and tech tips. Thanks for watching, and see you in the next time.